Sheesh! Beautiful. Alright, this is my audience.
No.
Yeah,
the 7.
there's a cat in there. Good evening, friends. Today I'd like to talk to you guys a little bit about the food that you all eat. Now, some of you may already know that the development of ammonia-based fertilizers has completely revolutionized the way that the food industry produces crops. Now, I'm here today to tell you that this industry is about to take an evolutionary step forward that will lower the cost of producing food and also make it more energy efficient to do so. Now, what is the catalyst to bring about this change, you may be asking yourselves? Well, interestingly enough, it is a chemical catalyst, and ironically, based on a protein that has been producing ammonia for far longer than we have been able to do so. Now, before I tell you more about this catalyst, I need to tell you a little bit about nitrogen fixing in general, the Haber-Bosch process, and finally, nitrogenase enzymes, as well as this inorganic catalyst. Nitrogenase is the process by which atmospheric nitrogen is converted into more reactive, useful forms. This is very important because nitrogen, as it exists in the atmosphere, is molecular nitrogen or dinitrogen, formula N2. It is connected, it's two nitrogen atoms connected by a triple bond that is very, very difficult to break. This poses a problem to plants who require reactive forms of nitrogen in order to synthesize nitrogen-containing proteins that are essential for plant life. Ammonia-containing fertilizers are a good way of sending fixed nitrogen to the soil for plants to use. We accomplish this today by the Haber-Bosch process. Now, the Haber-Bosch process was developed in 1909 by chemist Dr. Fritz Haber, who developed the Haber-Bosch process in order to help Germany with its food shortages it was experiencing during the First World War. Now, the Haber-Bosch process has been referred to by Vaclav Semel as the detonator for the population explosion, and is also responsible for the quadrupled efficiency of land dedicated to agriculture worldwide. That being said, the Haber-Bosch process is not without its downfalls. In order to break the dinitrogen triple bond, the Haber-Bosch process relies on extremely high temperatures and pressures. And in order to achieve these conditions, it consumes an absurd amount of energy. In fact, in 2007, the International Energy Outlook Committee estimated that the Haber-Bosch process is responsible for between 1 and 2% of the world's energy supply annually, the consumption of the world's energy supply. Anyway, that being said, alternative methods of nitrogen fixing has become a very hot topic of study for chemists and other scientists around the world who wish to attain international notoriety. Now, in 2013, a chemist by the name of Jonas Peters at Caltech and his research group synthesized a catalyst that was capable of producing ammonia at a similar capacity as the nitrogenase enzyme. Now, the nitrogenase enzyme, which has long been known for a very long time, although how it works has eluded scientists. One thing that we do know is that the nitrogenase enzyme has an active site that is referred to as the iron molybdenum cofactor because it consists of a center that is iron and molybdenum bonded to various phosphorus and carbon atoms. Now, whether it is iron or molybdenum that is responsible for the activity of this enzyme is unclear to scientists. However, the synthesis of the catalyst that can produce ammonia that is based on iron by Dr. Jonas Peters has been a beacon of hope of sorts for researchers in the field. Now, some do not completely agree. In fact, an MIT professor told Chemical World, quote, "It's a wonderful achievement, but proves nothing of nitrogenases." Now, he believes that his molybdenum catalyst is a more accurate model of nitrogenase activity. Well, whether it's molybdenum or iron that is responsible for the production of ammonia in the nitrogenase protein is still unclear. However, research in Dr. Peters' catalyst has led to very enlightening conclusions about the cofactor and its activity. One thing is very clear, and that is that if chemical catalysts can be a successful replacement for the Haber-Bosch process in the future, food production costs could potentially be lowered enough that that we can reach out to undeveloped nations and provide them with food without significant monetary loss, and potentially end world hunger. And that is some cool chemistry.